Hi, this probably will be the last episode in this series, at least for now. Let's rename a main function to start. Let's remove this multiplier from here, and let's add a simple background. So go into the project settings. Here let's change the environment color for something blue. Okay. And also add some simple ground. So let's steal polygon from here. And also steal this. Make our ground like this. And add our ground to the tree. Now we'll need to make our vertices. So if you have screen like this, then you will just put a ground here. So we have this, and this point. So we'll have 0, then maybe something like this. Okay. Vector 2, okay. Okay, so we have something like this. But it doesn't show. Okay, so we have something like this. Maybe make it a little bit darker. How much is this? This is too much. Okay, like this. Maybe also put it a little bit lower. Something like this. Okay. Now our tree, so our maybe add here something like limit bottom. Take this one, put it here. Okay, and take this, put here, and put this one up here. Now we can simply pass this here, and the tree should start from the ground like this. Okay. Change the tree color to maybe this saddle brown. And check how does it look like. Okay, let's make leaves bigger. So try to multiply this times 4. Maybe overdid this. Multiply by 2. Okay, let's add more of trees, but in different, put them in different positions. Maybe by 4, divide by 4. Okay. Okay. And now add some probability in our preset. Had this probability thing, and it works like this. Let's set this one to 80, and let's make a second option. And I don't know, I will be guessing make something like this maybe. Okay, let's check how those look like. So yeah, you can experiment with that as much as you want. Remember that you can, instead of drawing polygons in the leaves, you can add textures. You can also add the probability in different things like size, length, width. Okay, let's try now doing the same thing but with 3D. We will need to create another project. Here we'll be using a 3D scene. Let's make it almost the same as before. So call this one main, but add another node 3D here, and call this one generator, maybe. Okay, so besides, now we've created the generator, let's add some camera. Okay. I don't really work in 3D too much, but I think that there's something here with some default presets for the world. So let's add this, and let's add this, and let's see how does it look like. Okay, it used to be default previously, but seems that now we have to just add it. Okay. Now let's add the ground. So this will be the one, and he will take, I think, plane mesh. Okay, plane mesh works. And scale this one. Okay, how does it look like? We don't really see. Let's add some script to our camera. There is already a script for this. I will link this one in the description, but it allows us with a camera with WASD, and with the right click we can rotate. So let's go into our generator now, attach a script, and copy here our code from the file system 2D, and we're doing only remove the extend 2D into the 3D. Okay, so I know what's the problem. I don't know yet how to solve this, but basically here we need to rotate alongside the y-axis, and why is that I will show you here. So in the 3D editor I've created this cylinder mesh, here cylinder mesh as an example, and here we want to create the symmetry, and the trunk is alright, then the first branch is alright, but the second and third are going downwards but should be going upwards. And why is that? Is because we're drawing based on our direction vector, and here I will draw maybe this one. The direction vector here is pointing upwards, so basically 0, 1, 0. Here he's alright, he's not alright, he's rotated alright. Then we have the getting from the stack signs, and we get back here, but rotating this one returns the same vector. So we have to rotate it in some other way. You may not understand it, but I will show this on this cylinder example. Remember how this tree look like. Okay. Our trunk is going like this and to the right. Then we rotate along the x-axis, and we get the first trunk like here. Then we pop back from the stack. We're back here again. And what's the problem? So we want to have something like this, rotation along the y-axis. Then we'll have our branches in other direction. But like I said, the problem is with the rotating the normalized vector. Okay, so I will look for this one a little bit more and come back with the solution. It's been 4 days. I got punished because I said that this will probably be easy to do in 3D, but it was not. But finally, I've made this look. I know you may say that it still looks like crap, but what if I were to add more steps? Maybe speed this up a little bit. Looks a little bit better, doesn't it? And what if I now were to create some shapes instead of simple lines in 3D? Maybe even more steps. Looks pretty sweet, in my opinion at least. This is done without even a single mesh done beforehand. So okay, how does it work? I had to rethink everything once again and do it in a little bit different way. So let's see an example here. If I were to add a marker 2D, which was previously called position, marker 3D, not 2D, and then add another marker here. This one will be a start position. This one will be a end. This one will be an end position. Position of what? Of a single part of a branch, whatever you want to call it. We also add a mesh here, and for showing purposes, let's give it a cylinder mesh. Let me find this. Okay, cylinder mesh. And let's do it again, but as a child. As a child of end position. Okay, like this. Now, here we have to use a transform options in the Godot engine. In the 2D, we've been using a simple map, but here it's very complicated. I don't want to say impossible, but it shouldn't be done like that. If you want to read more about that, then I will link this site from the documentation about problems of the 3D rotation. Okay, but back to this thing. Here every position of every child will be related to its parent. So we set a starting position as 0, and then here, because the position of the cylinders is in its middle, and also the cylinder has a height of 2, for showing purposes we will set the position on 1. Let's hide this for now. But in the code, our mesh's position starts at the bottom. Okay. And also our end position will be set on 2. So basically on end of the cylinder. And our second start position also will be set on 2. So not on 2. Will be set on 0, equal to the end position. The second end position will be once again set on the end of cylinder. And that's on this one and this one. Also we need to transform by 1. And now, if we want to move a second, let's call it branch, we move its starting position, we rotate its starting position here. And by setting rotations here, we create this entire tree. Okay. If you're having problems while understanding this code, I recommend creating yourself here a tree like this, or you can run the code, and then you have a little button remote here, and you can look up how the tree looks like while it's running. Okay, back to the code. The basics are the same as what we were doing in the 2D. I reduced some things like those deltas here, etc. Because we are not using this, I don't say that it's not useful, but I didn't use it for now. I've used the presets from this site. I will link this in the description for this tree. The only things I've made myself are those multipliers and angle. Because they did not give the angle here, so I just put it as 30 and it works. And I also changed this sign for a single one and added a semicolon for scanning width. Okay, so back to the code and how does it work in a very high level. I've already showed it in the editor, but basically we create a global twin. Basically we randomize seed, but we don't use the any probability rules at the moment. We once again kickstart this from the start, but we pass as arguments. We create a global twin. We load settings. Here I changed because if I am correct, previously I was not converting this one to radians. Later I add some additional fields to our current state. Rota being rotation instead of direction, which I don't use anymore. And I am also creating a parent joint. This is basically for making a tree of nodes. And as a starting, we pass self, so the generator. Next we calculate. This is the same as before. And now we create parts. This was called something like draw parts before. But yeah, the basis is the same. Here we draw and here we take actions. I added the default here with the push error. If I were to use an unknown symbol here, I've changed the checkpoint a little bit. Now if you were to add something here, you don't have to add saving here, it will automatically load and save, but you have to keep the keys in the checkpoint same as in the current point. And this is the function where the magic happens. Make part. So here we define our starting position. If there is a rotation, we rotate, and if we rotate it, we remove the rotation because it's a one-time use only. This is very important here. This is the last problem that I had with this code, and it took a lot of time. Next, after defining this simple position, we add it as a child of our parent, and we make it as a last currently created joint. Then we need a end position of this branch, so we create a joint again here, and we want to have its position. I've made it return by the make animated mesh function. Here I just pass number of the size of our shape. So I think I've shown it before. If we were to have 4, we will have something like this, a big rectangle, but we want 8, so this one will look a little bit like a circle. Okay, and in our animated mesh function, we calculate our end position, which is relative to our parent's position. So we basically need height being our length. We create our size tool. So this is for creating a mesh. We will define how it will be rendered. I think that I also talked about this. We don't need this anymore because it's for lines. Here we're creating a cube shape. I think I also talked about it before. And here we add our tool as our mesh. But we also set its default scale as 0 so that we can twin our property and make it look like it's growing. So we'll always start from the 0 and end on the 1, so our default length here. And we return this end position which we created here. And after that we have our second marker, and we also add it as a last node so that it will be apparent later. And yes, if you're working 3D before, this may seem really simple for you, but I've been mainly working in 2D. Okay, so I think that I will be ending this now. I'm considering making one more video in this series, at least for now, with adding material and colors. but I'm not really sure about that. Maybe I leave it as is. Main blocks are. You should also remember that you can use that probability if you think that I should change something about the format of the video, so like show less debugging, show only results, talk in simple terms, or explain more or less, or you want to see something being done in this series, then maybe leave a comment with that. Okay. Thank you for watching the series. Bye.